Hello, my name is Trevor Brown, and this presentation will outline the secure network architecture I developed as part of my final project for CYB 525, Technology Implementation of Security Solutions at Grand Canyon University. In these next few minutes, I'll walk you through the network diagram, and I'll explain each component and how it contributes to the defense in depth, and I will summarize the results of my vulnerability scan and discuss the security implications of advanced networking technologies. So here's my full network diagram for a small mid-sized enterprise. The network is segmented and layered with multiple security controls to meet the requirements outlined in this due out for the week. Starting from the top, the traffic from the internet will first pass through the external firewall, which will filter unwanted internet connections and reinforce perimeter access. Traffic is then routed through the perimeter router to the DMZ, which in the DMZ, the proxy server and the email server are held. These services are isolated to reduce their exposure to the internal network. An internal firewall will separate the DMZ from the secure LAN and filter traffic more. And then after that is a core router which connects to the internal network, which includes department VLANs, network security tools and services as detailed. So when we look into the internal LAN and the department segmentation, we will see 5 departmental networks: the human resources, sales, operations, IT, and finance. And under human resources, you also have another component, which we'll get into directly later into the video. Each of these 5 departmental networks has its own switch, and each of the switches supporting 25 client devices. This segmentation reduces lateral movement in the event a malicious act is done. So this reinforces role-based access. Everybody in these different departments gets access to only what they need to have access to, and what they should have access to. That way, it is role-based based off of what they do for the organization. A DHCP server is placed in the LAN to manage IP address, IP allocation across the departments. Then the network, again, that component that I discussed just a little bit earlier. The network includes an air-gapped R&D system, which is separated from the rest of the network. It's under the HR departmental network. This will ensure sensitive research and proprietary data are by themselves isolated because of the sensitivity of the data in the event of a network breach. So we just want to isolate every different component so that none of them are affected by the potential for malicious intent in one area, to keep that from getting into the next area. Threat detection and network visibility. I integrated 3 open source tools in OSSEC, Tripwire, and Zeek. OSSEC agents are deployed on critical endpoints. So you can see the OSSEC is near my DMZ, and it is deployed on the email server and proxy server. And you can also find it on the finance department system. And this will report back to a central manager. So OSSEC will provide a host-based intrusion detection and can perform automated responses. It works hand in hand. It can work hand in hand with systems like Zeek, which is connected to a mirrored port on the core switch, as you can see in my diagram. This Zeek will monitor internal network traffic passively. logging anomalies without interfering the traffic flow. So the significance of Zeek is that it will not interfere with traffic flow. And that is where it's different from other IDS and IPSs. And then finally, we have Tripwire, which can be installed on high value systems like the finance servers or the air gapped R&D node, which have sensitive data. All nodes have sensitive data, but we have to understand which have more sensitive data than others. And that's where the tripwire will be. It monitors file integrity and alerts on unauthorized changes to critical configurations. So all these tools will provide a layered security. Zeek will monitor the traffic. Tripwire will ensure the systems have and maintain their integrity. And OSSEC will monitor the endpoints of the entire structure. To test this entire infrastructure that I just detailed, I initiated and completed a full and fast vulnerability scan. The scan actually only completed up to 30% before being stopped or halted due to a manager daemon error. But despite this, we have partial results that were collected and reviewed, and several of the devices responded to the scan, showing early indicators of common misconfigurations. That to include open ports and default services running. Um, um, and more of that data is in the rest of my report. Further on the report, so there are two hosts, 192.168.1.1 and .1.13 that were flagged for high severity vulnerabilities related to the outdated scanning environment. Additional issues included DNS and SSL TLS misconfigurations. Based on the partial data that I received from my scan that was not fully completed, but we can still get, strong information from this. I recommend updating vulnerable systems, continuing to harden the services, and trying the scan again to see what else we get from the scan. So as networks evolve, so do the threats, which is why it's important to always advance and update your network and the security functions that you have for your network periodically. Emerging technologies like 5G, Internet of Things, software-defined networking, SDN, they provide more attack surfaces, more areas and opportunities for threats and malicious software to infiltrate and conduct malicious operational complexities into the environment. For example, 5G increases speed, and it can reduce latency, but it also can make centralized traffic inspection more difficult. Internet of Things devices often lack built-in security, not to mention the end user and their basic cybersecurity hygiene techniques, making Internet of Things devices very susceptible to manipulation from malicious threats. And Internet of Things devices are hard to restrict segmentation and monitoring. SDN centralizes network control, which can improve flexibility, but also creates targets within the network for attackers if it's not secured properly. So again, the design that I created, segmentation, air gapping, and layered monitoring tools, they can help to mitigate a lot of these risks that come from these advanced security concerns. By providing a improved visibility, kind of also having the segmented location so that the area for any malicious intent is then lowered, because there are so many different areas that if one area is compromised, it should not get to another location. In closing, so this architecture that I built for this medium-sized enterprise is built on segmentation and defense in depth, things like those concepts. So with integrating Zeek, Tripwire, and OSSEC, this strengthens monitoring across the traffic, the host, and the system's integrity is maintained. I did face some difficulties with the GVM scan, some technical challenges, but this still helped with the risk identification, and we can go back and do the scan again. So with that being said, thank you for your time. I look forward to your feedback on this secure network design. Please see the documentation for references and additional technical details.